So there's two approaches we could take to solving this question here. The first method I'll start this time with is the u substitution method. So what we have is y is equal to e to the cos x. Now what we can do is say let u equal to cos x. So I'm going to replace the cos x in the question with u. So that cos x is going to come out and I'm going to replace it with the letter u. Now that means I have y equals e to the power of u instead of e to the power of cos x. So when I differentiate that, I actually can't get it in terms of x. I will have to differentiate it with respect to u. So I will be getting dy du. Now what we know about e to the power of x, or e to the power of u in this case, is that it is unchanged when we go to differentiate it. So e to the x is just e to the x, and e to the u is e to the u. So what we're going to need to do with that then is, if we want to get from dy du to dy dx, we're going to need to introduce a dx, and we're going to need to get rid of that du. So I need to multiply by du dx. Now can I find a du dx? So is there a connection between u and x somewhere? And there is. We had u is equal to cos x, so that means I could differentiate du with respect to x, and I will get minus sine x when I do that, nice and straightforward. So the formula here is telling me that if I want dy dx from dy du, I will need to multiply dy du by du dx. So do I have those pieces now? I do. So I have dy du, that was equal to e to the u. So I have this information here. I also now have du dx, so I have my minus sine x here. That's going to be filled in over here. And we're going to substitute them back in. So we've got dy du is equal to eu multiplied by du dx, which is multiplied by minus sine x. And that's not us finished. We have to now go back and put in our value for u. So instead of having e to the u, then we have e to the cos x, multiplied that then by minus sine x. And what we get out, if we write all of that out, is we get minus e to the cos x sine x.